Hello everyone, welcome back to my channel. We are solving chapter circles 7 marks question. So our 13th question is find the equation of the circles which touches the x-axis at a distance of 3 units from the origin and making an intercept of length 6 units on the y-axis. So we have circles which are touching at the x-axis at distance of 3 units. So from this side it will be minus 3 and here it is plus 3, so the another coordinate will be 0, right? So it is minus 3 comma 0 and 3 comma 0 can be our coordinates, and the y-intercept of distance from the origin is 6 units. So we have to find the equation of the circle. So we'll consider, let the equation of required circle S is equals to x square plus y square plus 2gx plus 2fy plus c equals to 0, equation 1. As we know that the the 2 points passes through the circle, right? So we can substitute these 2 points in the equation of circle. So minus 3 comma 0 and 3 comma 0 passes through 1. So first it is minus 3 comma 0. We substitute in this equation, we'll get minus 3 square plus 0 square plus 2g into minus 3 plus 2f into 0 plus c equal to 0. So this can be written as 3 square is 9 and here it is minus 6g plus c equals to 0. If we arrange it, it will be minus 6g plus c plus 9 equals to 0. Take it as equation 2. Now 3 comma 0 also passes through it, right? So we'll get the same equation but we'll get a positive term, right? So it will be 6g plus c plus 9 equal to 0 as equation 3. Now we need to remember that g square is equals to c, because since the circles touch the x-axis, this is the condition, g square equals to c. Now we can replace the value of c in this equation as g square. Okay, I will do for the equation 2. Substitute c is equals to g square in equation 2. So we will get minus 6g plus g square plus 9 equals to 0. So this can be written as g square minus 6g plus 9 equals to 0 arranged. So this is nothing but a square minus 2ab plus b square term. Okay, so for 9 we can write it as 3 square. So it can be written as g square minus 6g plus 3 square equals to 0. So a minus b whole square, so it is g minus 3 whole square equals to 0. From here we'll get the value of g, which is g is equals to plus 3. Okay, we'll get the value of c also. C is equals to g square, right? So g value is 3, so we can write it as c is equals to 3 square. So we'll get c is equals to 9. So we got the value of c and g. Now we have to find the value of f. For that, it is given in the question as length of y-intercept is equals to 6. So the length of y-intercept formula is 2 root f square minus c is equals to 6. 2 ones are 2, 2 threes are 6. So this can be written as root f square minus c is equals to 3. Now we have to do squaring on both sides in order to remove the root. So we'll get f square minus c is equals to 3 square is 9. Now substitute the value of c here, we'll get f square minus 9 is equals to 9. From here we'll get f square is equals to 9 plus 9. So we'll get f square is equals to 18. So the square comes over there, so it is plus or minus root 18, which can be written as plus or minus 9 into 2. So f is equals to plus or minus 3 root 2. So we got the value of f. There is a possibility that the g can also be equal to minus 3. Okay, if we substitute the value of c is equals to g square in equation 3, which is nothing but the positive form of equation 2, right? So if we do that, we'll get the value of g as minus 3. So g can also be written as plus or minus 3. Now we should substitute all the values in equation 1. Substitute g is equals to plus or minus 3, f is equals to plus or minus 3 root 2, c is equals to 9 in equation 1. So we'll get s is equals to x square plus y square plus 2gx plus 2fy plus c equals to 0. So s equals to x square plus y square plus 2 into the value of g plus or minus 3x plus 2 into plus or minus 3 root 2 the value of f into y plus c value 9. So s is equals to x square plus y square plus or minus 2 into 3 is 6x plus or minus 2 into 3 is 6 root 2y plus 9 equals to 0 is the required answer. Our 14th question is the polar of a point of x square plus y square is equals to a square with respect to the circle x square plus y square equal to b square touches the circle x square plus y square equals to c square, then show that ABC are in AP. So here there are three circles, right? And there is a point which is any point which is inside or outside of any circle, yeah, on the circle is called as the pole. Okay, and a line associated with this point, okay, yeah, which touches with this point is called as the polar. So this line is called as the polar here. Okay, so we have to prove that this a, b and c, the radiuses of these three circles, right, they are in gp. Okay, so we'll consider let p x1 comma y1 be a point on the circle x square plus y square is equals to a square. Then we can substitute that point here, so it is x1 square plus y1 square is equals to a square as equation 1. And now we'll write the equation of polar. The equation of polar of the point x1 comma y1 with respect to the circle x square plus y square equals to b square is x1 plus y1. We can transpose this b over there, so it is minus b square equals to 0. Okay, then this line is also a tangent to the third circle, right? This is a tangent, this polar line is a tangent to the third circle x square plus y square equals to c square. This line is a tangent to the circle x square plus y square is equals to c square. Then radius is equals to d, where d is equals to the perpendicular distance from 0 comma 0, right? The circle passes through the origin to the polar x1 plus y1 minus b square equals to 0. So which can be written as c is equals to, right, the third circle radius is c, r equals to d, so r value is here, the radius of the third circle which is c is equals to mod of 0 into x1 plus 0 into y1 minus b square by root x1 square plus y1 square. This is the distance, perpendicular distance formula. I hope you all know a x1 plus b y1 plus c by root a square plus b square, right? So this is c is equals to modulus of minus b square by root of, this is nothing but equation 1 value, right, which is equals to a square, right? We got this from 1 we got, okay? So c is equals to, if we remove the mod, it is positive b square by a square root of, so square and root gets cancelled, so we'll be remaining with b square is equals to ac. Therefore we can say that APC are in GP, geometric progression.